Good morning. Thank you for joining us. Today's webinar, Get Hooked on React, demonstrates how to use hooks, one of the newest features of React released about 1 week ago. Your presenter is Mark Volkman. Mark is an accomplished JavaScript React developer who has published numerous packages to the NPM repository. Note that we are recording today's session and we will distribute the video within 48 hours to everyone who registered. All participants are muted at this time. We encourage you to type your questions in the chat box. Many of you have already found that chat box. We will do our best to address those questions as we go, but for those questions that are left unanswered, we will answer those questions in a live Q&A session at the end. And with that said, I now turn it over to Mark, who will tell us all about hooks.
Good morning, everyone. I have all my contact information here on the first slide. I've got a lot of material to get through in an hour, so please, if you don't get your questions through or you come up with questions later, please feel free to shoot me an email. I'd be glad to help you with this. Also notice that there's a link to the slides there. It's actually a GitHub repo that hosts PDF files of all my talks from the last couple of years, so this hooks talk is just one of them that you'll find out there. Okay. Oh, here we go. All right, so hooks were released in alpha a while ago in a 16.7 alpha version, and about a week ago, 16.8 came out, and now they're ready for production use and no longer getting warnings about the API might change. So ready for you to use. And the biggest thing about hooks is that it lets you enable components that use state by using a function instead of writing a class. This doesn't mean that you can't implement components the way that you always have. That's not going to go away. But hooks provide a way to implement components that a lot of developers will find easier to understand. And you get to use these components together with your existing ones that are class-based. And you could choose to gradually incorporate use of hooks, or you don't have to ever use them if you don't want to. But this does make React the only one of the major web app frameworks that lets you implement a whole app using only functions. You never have to write a class. So for example, in Angular, you write classes for every component. And in Vue, while you don't have to write classes, you do define your components with an object that has methods on it. And we'll talk about some benefits of not having to do that coming up in a bit here. There are a couple of things that you cannot do with components that are implemented with hooks. And two of those are these lifecycle methods, component did catch and get snapshot before update. But fortunately, those aren't lifecycle hooks that are commonly used. And so that's probably not going to be an issue for you. So some of the benefits of using hooks, mainly that you don't have to understand certain things. So for some developers, probably not any of you, but for new people to JavaScript, understanding how the this keyword works can be a little bit confusing. And if you implement components using hooks, you don't have to worry about that. Also, when you're doing it in the class-based way, you often have to think about binding methods so that inside that code it knows what the proper value of this is. So these are just things you don't think about when you implement components using hooks. Hooks make it easier for you to deal with component state and using the context API. It's easier to reuse state logic between components. You could separate that out into a different function and have multiple components call that function to reuse that logic. Higher order components and render props have become kind of all the rage in React over the last few years. And they're fine, but it does make it so that your code gets more deeply nested. And with hooks, we're probably going to see a lot less use of higher order components and render props. Hooks make use of a thing called effects, which takes the place of a bunch of lifecycle methods. And one thing this does for us is it lets us better organize the code for setting up things like event listeners and getting access to resources. And I'll touch on that a bit more later. And then finally, something that isn't directly applicable to users of React, but more framework people, hooks are something that's easier to optimize than class-based components. And here I'm talking about the ability to minify the code, to perform hot reloading and tree shaking. And so the tooling, I think, is going to improve as we see more use of hooks. So there's some rules for making use of hooks. One is that you should start the name of all your hook functions with the word use. And I want to emphasize should. You don't have to do this, but if you follow this rule, then it means that some linting rules from ESLint can check to make sure that you're using hooks properly. And it gives a clue to developers that, hey, this is a function that might be doing something with the state of a component. You can only use hooks inside function-based components and inside custom hooks that you write. Can't use them in class-based components. A big thing about hooks is that you cannot call them conditionally. And what I mean here is that you can't call them from inside an if or an else block. Can't do it inside a loop or inside a nested function. And the reason for this is that React needs to know that every time it renders this component, that it's going to use the same hooks in the same order. And if there were, for example, conditional logic applied, it'd be possible that on some renderings of the component, you wouldn't use some of the hooks. So it's important that they be the same on every render. ESLint is a big tool in the JavaScript world, and React relies on this quite a bit for many of its features. And so hooks is just a new one. It provides a single rule at the moment called rules of hooks. And so if you add this to your ESLint configuration and set it up with a value of error, then it's going to make an assumption that any function whose name begins with use followed by an uppercase letter must be a hook. And if it's a hook, it's going to check to make sure that all your function components are the only ones that can call these, and that they're going to be called in the same order on every render. So it's really good for catching your possible misuse of hooks. There are a bunch of provided hooks that are in the React package, and if you want to use them, you import them like I'm showing on the screen here. So two of the most popular hooks to use are useState and useEffect. So here I'm showing how I would gain access to those. And on most of the slides that are following here, we're going to focus on the provided hooks and talk about how those work. Probably the most popular one is going to be the useState hook. This is a way that you can write a function-based component and have it hold on to its own state. So you just make a call to useState, and you pass it the initial value you want to use for that state, and it's going to give you back an array containing two things. The first is the current value of that piece of state, and the second is a function that you can call if you want to change it. And so in the example code you see here, I want to set up state to hold on to a pet's name, and I'm initializing it to Dasher. And then I also want to hold on to the breed of a pet, and I'm initializing that to Whippet. Every time this component renders again, this is going to get called, and we'll talk about the implications of that, I think, on the next slide. So those set functions, you can call with just a simple value. In this case, you could imagine the pet name is just a string. So I could call set pet name and pass it a different string. But I can also pass it a function. And in that case, that function will be invoked and it will be passed the current value. And then I just return what the new value is. That's good, for example, if I wanted to do something like take a piece of state that's a number and I want to multiply it by 2. I need the current value to compute what the new one is. Another important thing about these set functions is that if you call them and it results in changing the value of a piece of state, then that component is going to automatically re-render. It's a very key piece of useState, is to make sure that your component stays in sync with its current state. Often these pieces of state are just primitive values like a string or a Boolean or a number, but it can also be an object or an array, which is of course also an object. So whenever your piece of state is an object and you want to update its value, you have to remember to pass it the entire new value. And this is different from what you might be used to by calling setState on a class-based component, because in that case, it's doing a shallow merge of the value that you pass with the current value. But that is not what happens when you call these set functions. You have to pass it the whole object. So these useState calls get made every time the component is rendered. And so you might be wondering about how that works with initializing the value. And the answer there is that it only initializes it on the first call. So if I go back a slide and I look at that call to useState, or I'm passing it dasher to initialize the pet name, that's only going to happen on the first render. And after that, even though useState is called again, it's just going to return to me in pet name the current value. Another key thing that I neglected to mention about this example is that when I call useState, I'm not telling it the name of the state. And earlier we talked about how you have to call these hooks in the same order on every render. And so what that should come to mind for you here is that you don't have to identify it. It's the order that keeps track of whether the first piece of state is the pet name, and in this case, the second one is the pet breed. So here's a more full example of a component that uses this. And so I have this component whose name is pet, and you can see that it's just a plain function, and I'm making it the default export of this source file. And then up at the top, we see those lines that you've seen on a previous slide, setting up the state for the pet name and the pet breed. And then I'm going to set up some event handling functions inside here using arrow functions to say that when I call change breed, I'm going to pass it an event object. And on that, I can get to the target and then the value of that target. And then I'm just going to pass that to one of those set functions that I got from useState. And now that I have change breed and change name, I'm ready to tell it the JSX that I want to render. And so you see that I have an input in there for the name of the pet. And when I get a change event, I call change name, that'll be past the event, and then I'll be updating my piece of state. And the same way for the select element below, that's keeping track of the pet breed. It starts out displaying the current value of pet breed. And then if I change what's selected, it's going to call change breed. So you see it's very easy here for something that's just a plain function to say what state it wants to use and to set up event handling so that I can update that state when the user interacts with my form. So you don't have to really understand how this is working under the covers, but it's kind of interesting. And what is happening is that all the state values for a component get stored in a linked list. And so in my example earlier, pet name is the piece of state that's in the first node of the linked list, and pet breed is in the second node of that linked list. You might be wondering, well, what would happen, or how would I achieve having a piece of state that gets shared between multiple components? This useState hook that comes with React can't do that for you. It just holds state within one component. But you could use a custom hook that's called useTopState to achieve this. And you see in the line of example code that it's almost exactly like useState. The only difference is that it has an extra first argument. In this case, it's pet name. So you give a name to that piece of state, and it can be any string that you want as long as it's unique throughout your application and your calls to useTopState. So using this approach, I could do this in multiple components. And then the first one that gets rendered that makes this call to useTopState with a value of pet name for its state, that's the only one that's going to initialize it. And all the rest will just get the current value. And then if any of those components call the setPetName function to update it, they'll all be re-rendered. So if you're interested in that, I've got a link to where that can be found in NPM. It's a nice corollary to useState that lets you share state between multiple components. The next most popular provided hook is likely useEffect. And this is an alternative to some of the lifecycle methods you can have in class-based components. So in function-based components, you're not able to define lifecycle methods. And so useEffect fills that gap. And there are 3 of the lifecycle methods that it provides an alternative to, and that's component did mount, did update, and will unmount. So effects have 2 phases to them. There's a setup phase, and then there's a cleanup phase. And in the setup, well, that's where you would place code that would otherwise be in component did mount or component did update. And for the cleanup, well, that's like a component will unmount. So an example of where you might use something like this is that maybe when a component is first rendered, it has an input inside it, and you'd like to automatically move focus into that component. And I'll show an example like that much later in my talk when we talk about the ref hook, because you need to use that in conjunction with useEffect to make that work. So some examples of where you might use this. If I wanted to set up some kind of event listener, and then when I'm finished with this component, I'd like to unregister the event listener, well, then my setup is registering and my cleanup is unregistering. Similarly, if I need to set up a network connection inside some component, and when I'm done, I want to close that connection, then those are the setup and cleanup functionalities. Or maybe I want to set up a timeout or an interval in JavaScript, and then when I'm finished, I need to clear the timeout or the interval. And then an example where I only have the setup part, maybe I want to fetch some data in my component, and that could be calling a REST service. And there's no cleanup there, but I could do that in the setup portion of an effect. So the way that you use this is you call useEffect and you pass to it a function. And that function contains your setup code. In the example below there, my setup is really just the console log saying that I'm performing setup, but you could replace that with some code that actually does something. And then if there is a cleanup step for this effect, then you return a function that contains your cleanup code. Okay, so the code in useEffect is the setup, and what it returns is a function that performs the cleanup. And I can call useEffect any number of times inside a function component. And the reason to call it more than once is that if I'm doing different kinds of setup and cleanup, I'd like for each kind to be in its own useEffect. So if I wanted to set up a network connection, I'd do that in useEffect, and then I'd close the connection in the function that I'm returning. And then if I also wanted to create an interval, I would do that in a different useEffect. And that way, all the code that's related is bundled together in the same call to useEffect. So the way this works when the code executes is that in the first render of your component, all the code inside your component function runs. And when that's finished, then it looks at all of your effects. And then they run in order. And it's going to run the setup code only. Then if the component has to re-render, it will again run all the code inside the component function. Then it will run all the cleanup code in all your effects in the order that you've defined them. And when it's finished with that, it runs all the setup code again. Okay, so re-rendering means clean up what I did before and then set up again. You might have situations, and this is probably pretty common, where you don't really want to execute all of your setup code and your cleanup code every time the component re-renders. And so to avoid that, you pass a second argument to useEffect that's an array of variables. And these variables are ones that it's going to compare to their previous value. And if anything changed, then it decides, okay, I will run the cleanup and the setup again, but if nothing changed, I won't. And a common thing is to only want to run this setup code on the first pass or the first render. And to do that, you just supply an empty array as the second argument to useEffect. So we'll see an example like that later when I talk about moving the focus automatically into an input. Another hook that you might use somewhat frequently, but probably not as often as useState and useEffect, is useContext. And this gives us an easier way to work with the context API. So many of you are probably already familiar with the context API. And hooks do not change the way that you implement a context. You still have to create a class that extends from component and that renders a provider element. And I have a link to where you can read up on how to do that. But assuming that you've already implemented a context, the useContext hook just makes it easier to take advantage of that. So if I had a component called someContext that implements the context API, I could call useContext on that to set it up. And so in the example below, you see that I have a component called myComponent, and this is just a function-based component. And I'm calling useContext and passing some context to that. And then it just does the normal things that it would do, like getting some data out of the context. There I've got context.someData to retrieve some data from it. So context that is returned to you by calling useContext is just an object that gives you read-only access to all the properties in that context. And then it could also have methods attached to it that you could call to modify that state in the context. You could directly make changes to those properties on the context, and that would affect your local copy, but you're not really changing what is in the context state. It's kind of a shame that doing that doesn't get flagged as an error. You really shouldn't be trying to modify the context in that way. So the methods on the context could give you a way to modify the state inside that context. But another key thing about this is that just by calling use context, you have subscribed yourself to updates that happen to the state. And so if I have multiple components that call use context on the same context, they're all watching the same data. And if that data changes, they'll all re-render automatically. By default, what's happening here is that if anything in the context changes, that your component is going to re-render. But maybe your context holds, say, 30 different pieces of data and you're only using 3 of them. You'd like it to be the case that your component only re-renders if the 3 you care about have changed. And you can do that by making use of another hook called use callback. Before I get to that, though, I want to point out another custom hook called context easy. Actually, this isn't a custom hook, it's just a library that provides kind of a neat context pre-built for you. So this makes it so that you don't have to do anything with the context API yourself. You just use this library to get access to this special context, and then you pass it to use context. And then when you want to make changes to it, you just call these provided methods in the context: set, transform, delete, push, and so on. And all of those take a path to some data inside the context, a path that would be something like user.address.city. And so if I want to change it, I would say context.set, and then I would pass it the string user.address.city, and then I would pass it the new value for the city. So it's really flexible. It makes it so you don't have to implement a context, and you could use this as a way of managing all the shared state in your application, like a replacement for Redux. So you can find that out in NPM as well. All right, so let's talk about the use callback hook. So one use of this is to make it so that your component only re-renders when certain pieces of data you care about have changed. So this is returning a memoized value, and that means that it's remembering what its previous value was for this set of variables that you've identified. So often what you pass to this is a function, but it really could be anything. And so for callback functions that you use inside your component, things like functions that should be invoked when the user clicks a button, if you don't take advantage of this hook, your callback function will be recreated on every render, and that's not very desirable. So let's take a look at how you would do that. So here I see an example of an input where when it changes, I want to call this function that I'm creating on the fly. It's just an arrow function, and it will be passed an event. And then I'm going to call process event or process input, and I'm passing it the event, and then a current value for color and size. And then I write it again on the next line. And the only difference here is that I'm now using the use callback hook and passing that function to it. But I also have that array as the second argument where I pass it color and size. So these do exactly the same thing, except the second one is only going to recreate that callback function if the value of color or size has changed since the last time this component was rendered. And so by avoiding recreating the callback function, it means I'm helping out React to determine whether it really needs to re-render this component, and I'm going to get a performance benefit out of that. So in general, you want all of your callback functions like this to take advantage of the use callback hook. If your callback function doesn't depend on any variables, you can pass an empty array as the second argument, and that will mean that you're always going to use the same copy of that callback function. You'll never create a new one. But if you omit the second argument, what happens is that it will create a new version every time, which definitely defeats the purpose of even using the use callback hook. So I'm wondering why React didn't make it so that it would either be an error to do that, or that it would treat it the same as if you had passed an empty array. But that's something to watch for. You really never want to use the use callback hook without also passing it a second argument that is an array, at least an empty array. So the example I just talked about was using the use callback hook for callback functions. But the other use you should consider is as a substitute for where you would have used should component update in a class-based component. And what I'm after here is that I want to help out React by telling it, hey, if these values have not changed, don't even think about re-rendering this JSX. You don't even have to do the virtual DOM difference to determine that. And so all I do is I take all the JSX that I'm returning from the component and I wrap it in a call to use callback and then supply that second argument, which is an array of the things that would affect what I'm rendering. So in the example at the bottom, V1 and V2, those could be the values of props. They could be the values of pieces of state. That could be something that I compute inside the component. I'm just saying these are values where if they haven't changed since the last render, don't even consider re-rendering this JSX. Use memo is kind of similar to use callback, but the difference is that this always takes a function. Use callback can take a function, but it doesn't have to. So use memo is all about memoizing the result of a function. So for example, I have this math calculation at the bottom where I'm calculating the hypotenuse of a triangle, and we're all traveling back to middle school where we did this sort of thing. And I have a console log inside there just to demonstrate when it is that it actually repeats this calculation. And I've wrapped that function inside a call to use memo and said that if the values of X or Y have not changed, you don't need to recompute this. You can just return what the previous value was. So it's just an optimization for functions. But it only remembers the result from the last call. So for example, if I call this with X and Y values of 1 and 2, and then I call with values of 3 and 4, and then I call again with values of 1 and 2, it won't have remembered that. It only remembers the last call. There's another related thing, React.memo, and this is not a hook, it's a function that's actually been in React for a while. It was added in React 16.6. And this is like how we sometimes use pure component. If you write a class-based React component that extends from pure component instead of component, then it will automatically compare the props that are passed to that component, and it will only re-render it if any of those props have changed. So in the example at the bottom, I have this % component, and rather than just define it with a function, I'm wrapping that function inside a call to react.memo, and this function takes two props, a count and a total. I'm printing out when it's re-rendering just to make sure that this is actually working. And then I compute a %, and then I render a span that has that inside it. And this is going to make it so that if I give it the same value for count and total again, it'll know right away that there's no point in trying to re-render this. By default, this React memo function only does a shallow comparison of the props that are passed to it. You might have a case where you want to customize this comparison, and you can do that by passing a second argument to react.memo, and that is a function that is supposed to return true if it's okay to skip this render. And in this example, my component is taking 3 props, a count, a total, and a symbol. And this is a bit contrived, but I'm assuming here that I only want to re-render this if the count or the total changed, and I don't really care about symbol. So in skip render, I'm past the previous props and the next props, and I'm only comparing count and total. And I'm saying that if they are the same, I'm going to want to return true, which means I'm going to skip this render. So there's a lot of pieces here that are all about improving the efficiency of the rendering process. The reducer hook is very popular for some people and not for others. And so I don't want to spend a whole lot of time talking about this because I have a bunch of other material to get through. But if you have used Redux with React, you're already familiar with a lot of the pieces that are at play here. A reducer hook lets you do a similar thing to Redux, but confined to a single component. And so I want to use a reducer to manage state in just this one component. And so I'm demonstrating this with a very simple to-do app. And so I have a one component called to-do list. I happen to be styling it using Sass, which is not really an important part of this example, but kind of interesting on its own. Then I'm going to call use reducer, and that's going to give me back two things. I get back the current state, and I get a dispatch function that I can call whenever I want to make changes to the state. And when I call dispatch, I'm going to pass it an action object, just like in regular Redux. That action object is going to have a type and a payload. And then my component will only re-render when a call to dispatch causes my state to change. So going through this kind of quickly, here's my Sass file. And the main thing that you notice here is that I have nested rules. The topmost element in my to-do list component has a class on it of to-do list, and then all my other rules are nested inside that. And this gives me nice scoping of the CSS to just that one component without having to use one of the CSS and JS approaches. And then in my component itself, I can import that Sass file directly because that's a built-in feature of Create React App now to set it up so that you can use that. The only extra thing you have to do is to install the node package node-sass. So at the very top, I'm importing React and the hooks that I'm going to use, and I'm pulling in use callback and use reducer. Then I'm setting up what the initial state is going to be. So text is where I type in the text of a brand new to-do, and to-dos is an array of all of my to-do objects, and each of those have an ID, the text of the to-do, and a done property to say whether I've completed it. As I create to-dos, they all get assigned a new ID, and so I keep track of that in last ID. And then because my JSX I'm rendering does have a form element, I want to prevent the default processing of that because I'm going to handle all the processing of the form. So that's the point of this handle submit calling prevent default. So here's the reducer, and this is the part that will be really familiar to you if you've used Redux before. My reducer takes the state, the current state, and an action. My action has a type and a payload, so I'm destructuring those on the third line. My state only contains two things, the text and the to-dos. And then I go into a switch like a normal reducer, and I check to see what kind of action I received. And then based on that, I'm building the new state. And then at the very end, if I don't get an action type that I recognize, I'm returning the current state as Redux says that you should do. Then in the component itself, I'm calling use reducer, and I pass to it the reducer that we saw in the previous slide and the initial state that you saw 2 slides back. That gives me the current state and a dispatch function. And then I'm setting up all of my event handling. So if you try to add a new to-do, I want to dispatch an action with a type of add to-do. And you see that all of my event handling functions are wrapped in a call to use callback, and they all have an empty array as the second argument. This means that I only want to create these functions one time. So even though the function to-do list is going to run again on every render, I will not be creating brand new callback functions. Then we get to where I'm returning all of the JSX for this component. And you see that I have an input where you can enter the text for a brand new to-do. Its value starts out at state.text. And then if you make a change to it, it's going to call handle text. Handle text dispatches an action, which ends up updating that piece of data inside my state. We've got the handle add when you click the add button. Then I'm looping through all of the to-dos and creating a div with a class name of to-do for each of those. And each of those has a checkbox for toggling whether it's done. I'm displaying the text of the to-do with a CSS class that will either be done-true or done-false. When it's done-true, my CSS says that I should draw a line through it. And then we have an X button that you can click to delete it. So what do we think about this? This is nice if you're very familiar with Redux and you like that pattern, but one of the values of Redux is that it's typically managing all of the state for your application, or at least all of the shared state for your application. It also has another big benefit, which is the existence of the Redux dev tools, which allow you to, as you're debugging, look at a list of all the actions that have ever been dispatched in your application and look at what the state was after those ran, or to do things like time travel debugging. So these are all really big features of Redux, and every one of those goes away when you use this use reducer hook. You are only managing state for one component, not for the whole app, and there are no dev tools that will help you look at this state. So for me, use of this is a little bit questionable. I suppose if you have a really complicated component that is managing a lot of its own state, it might be useful in that setting. But for many people, I think that they'll go with the easier option, which is to take advantage of the use state hook. Looks like I messed up this slide. It was supposed to say use ref at the top, not BB. Obviously, I was doing something in Vim and typed some Vim characters. But the use ref hook gives you an alternative to where in a class-based component you would have instance variables. And the point here is I want to have a piece of data in the state of a component that survives across renders, but it's not really in the state. And the difference here is that when I make a change to the value of a ref, I don't want it to cause my component to re-render. It's just some data I'm carrying along. It's not really like state. So when I call use ref, if I want, I can give it an initial value. And in any case, that's going to return to me an object that has a property called current that has the current value in it. And a real common use of this is to capture a reference to a particular DOM node. So for example, back in my to-do app, I had an input where you could type in the text for a brand new to-do that you want to add. But what if I wanted to make it so that the first time that to-do list component renders, it automatically moves focus into that input? So to do that, I need two hooks here. I need use ref and I need use effect. So I'm going to import both of those. And then I'm going to create a ref just by calling use ref. I don't have to pass anything to it if I don't need it to have an initial value. And then I need to use an effect because when my component mounts, I want to find that input and I want to move focus into it. And for this to work, that ref has to have a reference to the input. So the fourth step is that in my JSX, when I create the input, I need to say ref equals and point it to my input ref. So when it renders the first time, it's going to set input ref to be a reference to the DOM node of that input. And then when component did mount would happen, that's when my use effect is going to fire. And so it's going to call the function I passed to use effect. At that point, input ref.current will have a value, and I can call focus on it. I am passing an empty array as the second argument of use effect because I only want to move the focus into that input on the first render. Okay, so a lot of pieces pulled together here, but just with a few simple changes to the previous code you saw, we're able to make this work so that I can get focus into that input. Another example of using a ref hook is when I'm not pointing to a DOM node, but I just want to hold on to a value. So suppose in my to-do list app, I want to keep track of how many to-dos have been deleted. So what I could do is I could use ref to create what I'm calling delete count ref. And in this case, I do want to initialize it. I want to start it at 0. And then in my event handling for the delete button, I want to give it a function, and that function is going to be passed the ID that's going to be deleted. So that's the same code as I had before. The thing that's different here is what I've outlined in red. So every time I delete something, I'm not only dispatching an action for the reducer, but I'm going to bump up my count in the delete count ref. And notice that you have to refer to it with .current. That's the property on the object you get back from useRef that actually has the value. And then I'm printing out how many have been deleted. And so now every time I delete one, it's going to bump up the count and then print that out for me. So ref hooks can hold on to any kind of value. And remember, the key difference between a ref and a piece of state is that changing the value of a ref does not cause your component to re-render. There are other provided hooks that I won't take time to talk about. So the imperative handle hook is one of those. You can check out the slides later and read up on that. Another one is the layout effect hook. But now I want to talk a bit about custom hooks. So a custom hook should be a function whose name begins with use, and it should make calls to other hooks. And often this hook is going to return an array or an object that has some state data in it. Maybe it has some functions that you can call to modify that state. And the main use of these is so that you can extract some functionality out of a component that is doing something with your state, because that same functionality is needed in more than one component and you'd like to share it. So that's a big thing custom hooks do, is let you share this functionality across components. So I want to walk through two examples that Dan Abramov shared when he was giving a talk about hooks. So the first of these is, suppose I have multiple components that need to change what they render based on the width of the window. You could imagine perhaps wanting to do this as a way of supporting mobile devices. Perhaps you render things in a different way or render less when you're on mobile. And so I can write this function, use window width. I know it's a hook because it begins with use. And then inside it, I'm making use of other hooks. And in this case, those hooks are use state and use effect. So I want to hold on to the current width of the window. And so I call use state and I pass to it window.innerWidth. So there I'm just making use of the DOM to get the current value. And that's going to only be initialized on the first call. And it's going to pass back to me what is the current width, and it will give me a function that I can call to update that piece of state. Then I want to set up an effect so that the first time a component that uses this hook renders, it will call this. And so on the first call, I want to set up a callback function that will be called whenever the window is resized. And so handle resize is just a function that when I call it, it will call set width, passing it the current width of the window so that I update that piece of the state. And then I'm going to register this listener on the window so that whenever I get a resize event, it will call that function. I do have some cleanup. When a component that uses this goes away, I need to stop listening for those resize events. And so I'm going to remove the event listener resize. And the function that I'm going to stop using as a listener is handle resize. Notice that I'm passing a second argument to use effect that's an empty array. I only want to run this code on the first render, and I'm only going to do the cleanup when this component is no longer being used. And then finally, I'm returning the current width. So with all of this functionality tucked away in this custom hook, any component can now use it like you see at the bottom. It just needs to call use window width, and it will get back the current width. And I know that anytime the window width changes, every component that is using use window width will be re-rendered. So that's great. It'll just happen automatically, and I didn't have to duplicate that logic inside all of those components. Another example is for handling form inputs. And this could be any kind of form input, text or a text area, it could be a checkbox, a radio button, any of those sorts of things. And so here we have a hook where I'm going to pass in the initial value of some form input. And inside, I just want to take advantage of use state to hold on to that initial value. And then every time this is called, I'm going to get back what is the current value, and then a function that I can call to change it. So I want to return from this hook things that would be useful inside an input. And the input wants to have an on change prop. that will be called when the user changes the value, and I need the current value so that it knows what to render right now. So in useState, we were getting back an array of two things, but here I'm returning an object. And the reason is that that is more convenient for the way that it's used at the bottom. Notice how at the very bottom, I'm taking the value of name props that I got by calling useFormInput, and I'm spreading those props into input. And so that means it gets an onChange and a value prop just through use of the spread operator. So imagine that I have a component that has a bunch of form elements on it, and I could take advantage of useFormInput inside that component for each of my inputs. And obviously they would go into variables with different names. I could have name props, age props, password props, and they would all be spread separately into different inputs. Okay, so I don't need to use a custom hook like this to achieve that. But by setting that up with just a few lines of code, I'm greatly simplifying all the places in my code where I have to handle form inputs. But there is a big assumption that I'm making here, and that assumption is that each component that has form elements in it, like what you see at the bottom, wants to hold on to its own state. And I'm assuming that it does not want to put it in a central place like Redux or in the context API. So this is a great approach for components that do want to manage their own state. Another hook that is provided is useDebugValue, and I won't spend much time on this. I just want to point out that when you're writing custom hooks, when you go into the React Dev Tools, there's a place where you can see those. When you select a component, like the one I'm showing here, I have pet selected, and the pet component uses two hooks, form input and state. So form input is the one that we just walked through. But what I really want to point out here is that notice that after form input, you see this value equals dasher. And that's what's coming from my use of useDebugValue. Any hook can make a call to that, and that's just providing some primitive value, string or a number or Boolean, that you'd like to display after the name of a hook in the dev tools just to help you out with your debugging. There are a lot of third-party hooks that people have started creating. You could find a list of those at the URL that I have listed there. I've written a couple of them. We've talked about those. That's the top state hook and context easy, which is not a hook, but it provides a context that you can use with the provided use context hook. So I think hooks are a really great addition to React. They're going to make it so much easier to implement components, and they probably spell the end of most people implementing their components using classes. There's certainly some debate about this on Twitter right now. Some people are wondering, why did we need hooks? Can't I just use class-based hooks? And of course, the answer is you can keep doing that, but I think the majority of React developers are going to prefer to implement their components using hooks. Also, I think we're going to see much less use of things like higher order components and render props, just because hooks clean up the code so much. For one thing, they dramatically reduce how much nesting is happening in your code, makes it easier to read. So I think it's a really good idea to make a move towards more use of hooks. So I have a list of some resources that you can check out, some articles and videos of talks that you could see online. My slides are out in my GitHub repo, in a repo called Talks, so definitely feel free to check those out. And as I said in the beginning, you have my email address. Let me flip back to that. Definitely feel free to shoot me an email if you have any questions about anything that we've covered today. So we've got some extra time now, 10 minutes. So if anybody's got questions, I'd love to field those now. Okay, here's our first question. You said you can use multiple effects in one component. How do you distinguish the calls to each use effect? Does the method have to be called use effect? Okay, so when you call use effect, that is a hook, and you can call it as many times as you want, and the way that it distinguishes, well, it kind of doesn't. It's just going to call the code in the functions that you pass to useEffect in the order that you call useEffect. So if I want to have 3 effects, I call useEffect 3 times. I pass each one a different function, and I'll know that on the first render, it's going to do the setup portion of all of those in the order that I've called useEffect. And in subsequent renders, it will run their cleanup portions in the order I've defined them, followed by their setup portions in the order I defined them. So each effect, it doesn't like have a name. It's just based on the order in which I've passed functions to useEffect. Any other questions? Is Vue still better than React? That's an interesting question. As it turns out, in the last month, I've been spending quite a bit of time learning about Vue, and so I feel like I can kind of speak to this. I think that I still have a slight preference for React, but I like Vue a lot. But I would say that one of the downsides of Vue is that the error messages are sometimes not very good. And I've been disappointed by the number of times that the result of an error is that I get a stack trace and there's nothing in that stack trace that's my code. And so it can make it hard to track down errors. Also, a thing that I mentioned in the beginning of this talk is that with hooks, React is now the only major framework that lets you implement everything with plain JavaScript functions. So you can't do that in Vue. In Vue, when you define a component, you are doing it with an object that has a bunch of props on it. Things like a prop that is called props, a prop that is called data and methods and watch and all these things. And so it's just a literal object that defines a Vue component. And that's fine, but it means that you have a bunch of things that are just separated by commas. And it also means that you must take advantage of the this keyword and know when to use it. And that's a thing you can get away with from doing when you use React hooks, is you don't have to think about the this keyword anymore. But that said, I liked Vue a lot. I just like React a slight bit more. Someone asked, could you talk a bit more about hooks and React dev tools? So let me go back to the slide that showed that. So that's when I was talking about the debug value hook. Okay, here it is. So in the screenshot in the lower right there, we're looking at a picture of the React Dev Tools. And notice that Elements is selected. And I'm digging down through the hierarchy of my React components. And so the topmost component is app. And then nested inside that, we have the pet component. And so what's happening here is you just select any React component, and that will let you see what were the props on that component. In this particular one, it didn't have any props, but it will also list what hooks that component uses and then let you see some data in them. And some of your pieces here might contain their own state. And so what I'm seeing here is that the pet component itself has a piece of state with the value of whippet. And it uses, the pet component uses the form input hook, and that has its own piece of state. It has a value of dasher. So that's really all there is to it. The React Dev Tools let you select a component and see if it uses any hooks, and if it does, what state is inside those. Okay. Yeah, so someone said, personally, I don't understand the objections to writing classes, particularly now that they've been standardized in ES6. Understanding this is just as complicated as in functions as it is in classes. A lot of people have that viewpoint, so you're not alone there. I would just say that for some people, the reason that they don't want to use classes is that they want to do more functional programming, and they really like having everything just be a plain function. So that's one group of people. Another group of people is ones that are maybe new to web development and they haven't previously used an object-oriented language where they were exposed to this. So maybe they've never done anything with Java or C++ or C#, and so they're just not familiar with that concept. And so not having to deal with that maybe makes an easier inroad for them to get into web development and not have to learn it. But I'm sure, like me, many of you have many years of experience in doing object-oriented programming. This is not new to you. You've been working in many languages that make use of this keyword, and you're not confused by it. A lot of people claim that understanding how this works is more difficult in JavaScript than it is in some other languages. I don't necessarily agree with that myself. So certainly you can continue using classes, and maybe this is going to kind of split the community a bit by people that want to continue making class-based components and people that refuse to do that, and we'll see a bit of a mixture. But I think if you take any particular component and you write it both ways, with a class or with a function, I think you'll find that in almost every case, you're going to have less code if you write it with a function. And so there's some draw to just that aspect of it. Another question is there some overlap between using use top state and context easy? If so, when is it better to use one over the other? Yes, there's definitely a big overlap there. I think use top state is a little bit easier to understand, but it has the downside that you are responsible for coming up with unique names for these pieces of state, making sure you use them consistently throughout your app. Also, all of the state is not really gathered in one big object that you can look at, where when you use context easy, all of the state is in this one context object, and it even provides a log flag where when it's set, every time you make a change to something, it's going to print out what did you call to change it, what did you pass, and what is the new state. And it puts that out in the DevTools console. And so like you're used to seeing in the DevTools console, when you print out an object, it gives those disclosure triangles and you can dig down through the structure of an object. Well, that's the way that is. And so at any point when you're using context easy and your code has made a change to the state, you'll be able to look at the entire state in the DevTools, where when you use top state, you can't do that. It's all kind of hidden away. So the benefit of use top state, it's easier to understand. The benefit of context easy is that it's probably better for debugging that way. Another question, what is your preferred approach for managing state which is global, shared by many components? My answer to that right now is when I'm working in React, my preference would be to use context easy. But just to throw this out there, I also have another library that is called Redux Easy, which is just like context easy. It's just that instead of using the context API, it uses Redux. So you have that as an option as well. So there's really three choices that I've developed for React. There's Redux Easy, Context Easy, and the top state hook. So all three of those could be used. And if you happen to like Vue, I've implemented the same thing for Vue in a library called Vuex Easy. Same API for all of those things. Another question, what's going to happen to the context API? Do you think it might be going away? Actually, I think it might become more popular because of the use context hook. The use context hook makes it easier to use context, and so I think more people will do it. If something is going away to any extent at all, in some sense this is sad, but I think the use of Redux is going to be on the decline, replaced by additional use of the context API. I don't think the introduction of hooks is going to hurt adoption of the context API, because use state only helps when you are trying to hold state inside a single component and not share it across them. But I understand people having a strong commitment to Redux. There's a certain appreciation for the pattern that it brings to the table. And so if you feel that way, you ought to check out Redux Easy and see what you think of that. just like, well, I should say about Redux Easy, when you use that, actions are still being dispatched on your behalf. It's just that you don't have to be the one that's dispatching them. And they still get tracked inside the Redux dev tools so that you can see that when you're debugging and still do time travel debugging. So I think that's all the time that we have today. Thank you very much for all the questions. Again, grab my email. It's just mark@objectcomputing.com, and send me lots of follow-up questions. I'd be glad to help.